Good morning. Today is Thursday, our first week of e-learning. As we progress through our momentum and impulse unit, we've covered the momentum part, which has to do with the mass times the velocity or the change in velocity of an object. Now we're talking about the impulse part. When things collide, forces act for a period of time. So we're going to first define what is impulse. So impulse is the product of the net force, net average force, acting on an object and the time over which the force acts. So we're talking about this force that's acting on the object and the time, okay? And we said it's the product. So product is when you multiply. So our equation is this. Now, the word impulse does start with an I, but in physics, rather than using the letter I, because we use it someplace else in electricity, they use the letter J. So J stands for impulse. Equals the product of the net force, right here, force, so we use a capital F for force, and we can put net there, times the time, we always use the little t. Okay, so we're going to say the unit that we're going to use, or the symbol that we're going to use for impulse is this capital J. Okay, so they just use a capital J because I has already been used up somewhere else and it's in electricity. Okay, now we haven't covered electricity yet, but we should be able to see that is. What's our unit that forces are measured in? Aren't they newtons? And then we're multiplying times. What's time? Isn't this seconds? Isn't that the units that we typically do? So it's a newton per second. So it can be written like this, a newton times a second. Okay? Now, I'm going to look at what is a newton times a second? What does that cancel out to be? Well, if we remember, a newton is a kilogram times a meter per second squared. I'm going to write seconds times a second because we have this second here, so I got to put it here. If I look at this, doesn't this second cancel out this second? And so doesn't this end up being a kilogram times meter per second? Okay, now, isn't this the same units as momentum? It is. So that means that impulse is equal to momentum. So I'm going to come down here and write this. So I could say J, which is impulse, equals the change in P, which is momentum. Okay, now I'm going to go back up here and go, hey, what did J equal? What did impulse equal? Wasn't that the force times the time, right? That's what we got up here, newtons times seconds, equals the mass times the change in V, the change in velocity. So there is our equation. They call this the impulse momentum equation. Okay, so that's just saying those two are equal to each other during collision. So we're talking about like when two balls would hit each other colliding, or two cars hitting each other during a collision. So we can represent this graphically. I could do it two different ways because I could have two different instances. So if I did the force over here and the time, I could have a constant force. So this would be a constant force. So if something was pushing on something constantly for a period of time, I don't care what it is, 2 seconds. Or I could do something like this where the force is not constant. So let's say the force increases and then the force decreases. So this would be a non-constant force, because the force is changing. At first it's increasing and then it is decreasing. Okay, so this would be my force. Force versus time. Okay, now I'm going to shade these in. This area underneath this graph, it's a rectangle, and the area under this one, the triangle, those areas represent the impulse. Because aren't you taking force times time, the product of those two? Okay, so that's exactly what we're doing. We're saying that's how you could represent it graphically. So this is our main equation that we are really interested in, is saying how does, when a collision happens, there's a force on an object for a period of time, how does that relate to the mass and the change in V? Okay. So an example problem would look like this. We have a man who has a mass of 100 kilograms, and he's running at a speed of 20 meters per second. He comes to a halt in 5 seconds. What is the man's impulse? And then they said, what force is required to stop the man? Okay, so we should know that impulse equals the change in momentum. And our equation is force times time equals mass times change in V. Let's look what we have. This is mass, right? This is his running speed at 20, and he comes to a halt. Isn't he going to be going 0 here? And he does it in 5 seconds. We want to know, what is his impulse? Well, we know his change in momentum is equal to his impulse. So if we can figure out this right here, don't we know this is equal to this? Yes. So his mass would be 100 kilograms times his change in velocity. Remember, change in V is also always velocity final minus velocity initial. So if I go, velocity final is 0 minus, he was going 20 meters per second. 0 minus a negative, minus 20 is a negative 20 meters per second times 100 kilograms. Doesn't he have an impulse of a negative 2,000 kilograms times meters per second? Okay, that's what his momentum would be. And that's what his impulse would be too, because those two are equal. Now they want to know what force is required to stop him. So we're looking at this. What is the force right here required to stop him? So since we know that this is the change in momentum, and now we just need to look at, hey, what is this force right here required to stop him? Can't I say the force times the time equals a negative 2,000 kilograms times meters per second? And I know my time is 5 seconds equals a negative 2,000 kilograms times meters per second times F. So it looks like I need to divide by 5 on each side. I'm going to do that over here, 5 seconds. 5 goes into a negative 2,000. A negative 400. And my units on this would be kilogram times meter over seconds, and then this is seconds would have been down here, seconds times seconds. Isn't this what a force is? A kilogram times meter per second squared? That's what I would get, because that is the force that it takes to stop him. This force right here, it's negative, because isn't this force acting against his motion? Yes, it is against his motion. Okay, so I want to go, your assignment for tomorrow is to do the problems 1 through 4 on assignment 4. I want to go and do a problem, and I think I'll do number 7. Okay, so as we're doing these problems, what we're looking at is the equation using impulse equals change in momentum. So we have J equals change in P, or we can write J out. It's force times time equals mass times the change in V. So I'm just going and I'm breaking it down into its basic units. Okay? So look at, they're telling you the average force exerted on a 5 kilogram shell in a gun barrel is 5,000 newtons. Calculate the velocity of the bullet after firing if it happens in 0.02 seconds. So in other words, I'm not an artist, so somebody's got a gun. There's the barrel. And they're going to fire this bullet. Okay? Now, the bullet's going to move like this. What direction is the force in? Well, isn't the gases blowing up back here? Isn't that what's pushing the bullet? So aren't they also pushing it in the same direction? So we got our velocity and our force are in the same direction. Okay, so since they're in the same direction, we're going to keep them positive. And I drew this to the right. So I know that my force is 5,000 newtons times, I know the time here, 0.02 seconds equals, and I also know that this shell is 5 kilograms. This is a large shell. And I want to figure out what is the change in V. So the change in V is always the velocity final minus the velocity initial. Well, when this shell is sitting in the gun here, when it's sitting over here in the gun before it is fired, it doesn't have any velocity. It's at rest. We want to know how fast is it going to be moving after this time. So I'm going to say my velocity final is, I don't know, minus my initial is 0. So doing a little math here, 5,000 times 0.02 is 100 newtons times seconds equals 5 kilograms times VF minus 0. Let's get rid of the 5. Divide. Do the same thing over here. 5 kilograms. 5 goes into 100 20 times. So 20, and if I look at my units here, it's a newton times second over kilograms equals VF minus 0. Well, guess what? Doesn't this equal my velocity final? Because isn't 20 minus 0 equal to 20? Yes. So velocity final equals 20. I'm going to also look at my units on here to show you how these units do come out to be meters per second. A newton is equal to a kilogram times meter over second times second. And then I also have this second I have to deal with times a second. Then I have kilograms right here I need to deal with. That's right here. Times kilograms. So I'm just bringing down my units. Okay? Look at kilograms would cancel out. This second would cancel out one of these seconds. I end up with meters per second. So my answer is in meters per second. Okay? I'm not saying that you need to analyze the units. Sometimes, I mean, I would think by now, since we have done this several times, that you would recognize that we're talking about a velocity here. It is in meters per second. You are supposed to do the assignment on pages